Hello everyone, welcome back to the channel. In this video, we will explore two key techniques that every iOS developer should know in RxSwift: do operator and the debug observable events. So, do operator, using the do operator to register an action for the lifecycle event in an observable. We will show how to perform the task like logging and executing business logic while letting the observable continue emitting the events. Second is debugging observable events. Debugging your RxSwift code to track the observable events and understand what's going on under the hood. We will walk through the code with the practical example explaining how the do operator works, how to observe different lifecycle events like on subscribe, on next, on completed, and more, and how you can debug your observable sequences using the debug operator. Whether you are a beginner or any experienced developer, this tutorial will help you to gain the better understanding of debugging skills. So let's get started. So I have created a function called the do operator, which contains the observable and that emits the value 1 2 3 4. We subscribe to that to this observable and handle the events for on next, on error, on completed, and on disposed. So I have also used the do operator to observe the life cycle of observable prior to the emitting the values to the subscribers. Inside the do operator, we have defined the closure for the events like on next, on error, on completed, on subscribe, on subscribed, on dispose, uh, with the print statement for our better understandings. So now let me run this piece of code and we'll check the output. Now, if you check the console log, you will see the following sequence: will subscribe, did subscribe, follow by the will next, will on next. This shows that you can access the next event before it reaches to the subscriber. However, you can't modify or alter the value inside the do operator. You can only observe it and perform any necessary business logic. After that, you will see will completed observable and then completed. And finally, the subscription disposed event is triggered first, followed by the operators did on dispose event. So if you see here, this is log is coming from the do operator. Then it is go to the in subscribe. Then it is go back to the do operator, and again it will go to the subscribe, and it is again back to the do operator. So the do operator will use to debug your RxSwift code and read values and figure out where you went wrong. Also, you can write your own business logic based on the observable lifecycle. There is another way. So there is another way to debug your RxSwift subscribe code using the debug function. So using the debug function. Now, if you see this code, the observable emits the sequence that is 1 2 3 4, and before subscribe to the observable, I have called debug function. So let me run this piece of code and we will check the output. So as you see here in the in the console, as each event occurs, the debug operator logs defined the lifecycle information. So this is coming from the debug, and this is coming from the subscribed. This is again coming from the debug. These two are coming from the subscribe, and again this is coming from the debug function. So the subscribe block prints each emitted value by the on next, prints on completed when the observable completed, and print on dispose when the subscription is disposed of. The subscription is managed by the dispose bag, ensuring that it's properly disposed of when no longer needed. To summarize this video, using the do operator, we have seen how to perform the tasks like logging and executing business logic while letting the observable continue emitting the events. Uh, Using debug functions, you can log the observable lifecycle events. I hope this video helped you to clarify how do and debug functions works in RxSwift. If you have any questions, let me know in the comment below. If you enjoy this video, don't forget to hit the like button, subscribe and ring the bell for more RxSwift tutorials. Thank you for watching and happy coding.